Welcome to our Teams IT Pro Academy training. This is a multi-part training on direct routing. In this lesson, we will be covering configuring and managing direct routing with Microsoft Teams. In addition to this training, you can find other IT Pro Academy trainings at our aka.ms/Teams Academy link. If you have feedback that you'd like to provide on this session, you can see the links and instructions noted on the slide here. If you have feedback on the product itself, make sure that you follow our aka.ms/Teams feedback link. You can see at the bottom of the slide the current version of this presentation. Now, some of the key learnings that we're going to cover in this session. Direct routing allows you to connect your existing phone infrastructure to the Microsoft Teams service. Direct routing itself will require a certified session border controller. Now, we'll cover what those are as we go throughout the presentation. We will also cover the configuration for direct routing in detail during the session, but we do also have it clearly documented on our docs portal. Let's take a look at the full agenda for the multi-part training on direct routing. The first lesson will cover what is direct routing, when to use it, and how to properly plan for direct routing. The second lesson will cover configuring direct routing and managing direct routing. And the third lesson will cover migrating to direct routing. The lesson that you're currently taking is highlighted on this slide. Let's begin this lesson by talking about configuration of direct routing. The configuration steps for direct routing are outlined on the slide. Starting on the left, you'll see that we'll begin by configuring the session border controller itself. Once we've properly configured the SBC, we will then connect or register the SBC with the online service. From there, we can configure the voice routing so that we understand how to properly route calls to the public switch telephone network. And then optionally, if necessary, we can configure the translation of phone numbers. Finally, our last step will be to enable the users for direct routing. When configuring the session border controller itself, we'll want to ensure that we follow the configuration documentation that is provided by the specific SBC vendors. If you follow the aka.ms link on this slide, that will take you to a landing page where you can jump to the respective documentation for the specific SBC vendor of choice. At a high level, the configuration of the SBC will include items such as configuration of the SBC license, a configuration of the LAN and WAN IP interfaces, configuration of the certificate used on the device itself, the configuration of the ports used for both signaling and media, the configuration of the SIP options, as well as secure RTP, which is encrypted media, the codecs that will be used both between the session border controller and Teams, as well as between the session border controller and whatever other telephony component you're interconnecting. And finally, the routing that is necessary to route the calls from the Teams environment to the PSTN, from the PSTN to Teams, and to any other telephony components that you are interconnecting with the session border controller. On the service side, we connect or register the session border controller using a PowerShell commandlet, new-CsOnlinePSTNGateway. This will allow the service to realize the FQDN of the session border controller, the port that the session border controller will be listening on, the maximum concurrent sessions that the SBC is capable of handling, and whether the session border controller is enabled or not. The parameters that I'm showing here are some of the basic minimum parameters that we need to set. You can see by running this commandlet, I've registered the SBC by name. So this could be sbc1.contoso.com, for example. The port that my SBC is listening on is 5068. I have set the max concurrent sessions to 50. This is not a requirement, but it's a really good practice to get into because you can align this together with the maximum call limit that the SBC itself can configure. That way the system will know if there are too many calls, we don't send any more calls to that session border controller because it's at capacity. And then of course, enabled true, you could set this enabled false if you were taking it out for maintenance or things of that nature. Right. There are some other optional settings that you see here that I'll cover on the remaining slides, but you can see this is the basic commandlet that we need to run to register the session border controller with the service. Now remember, the domain portion that we use for the SBC must match one of the registered domains, one of the vanity domains we have in the tenant. Remember that you cannot use the .onmicrosoft.com domain name as we talked about in the planning module. This slide and the next slide cover some of the more common parameters that we will use with the CsOnlinePSTNGateway tenant remote PowerShell commandlet. This is not an exhaustive list of parameters. This is just some of the more common ones that we will use when we configure the session border controller in the service. We have to configure the SIP signaling port, right? This is to let us know what port the session border controller is listening on for the SIP connection, for the service to be able to make the SIP connection into. Of course, we need to tell whether this is enabled or not. These two items, forward PAI and forward call history. Forward PAI indicates whether we use the P asserted identity, which is what PAI stands for, whether this header will be forwarded along with the call. This PAI header is important for providing a way to verify the identity of the caller. The default for this will be false, so if you want to use this, you need to make sure you explicitly set it to true. Likewise, you can use this forward call history parameter, which will indicate whether call history information is forwarded through the trunk. If, in fact, we do set this to true, the SIP proxy that we use in the service will actually send two additional headers, the history info and the referred by headers. Again, if you want to use this, you need to explicitly set this to be true because the default is false. Some other common parameters that we use, SIP options enabled. This should always be true, and it is true by default, because the SIP options is a polling mechanism that we use to ensure that the gateway is still alive and well. If we turn off SIP options, we don't really have a way to monitor and alert whether the SBC has gone offline or not. So always a good idea to keep these enabled. Max concurrent sessions, another parameter that can be used by the alerting system and is great to align this to the maximum sessions that you configure on the session border controller. That way, if the number of concurrent sessions is 90% or higher than whatever this value is, you'll get an alert in the admin console to let you know that this gateway is nearing capacity. You can set enable fast failover timer. When this is true, outbound calls that aren't answered by the gateway within a 10-second interval can get routed to the next available trunk. And if there aren't any additional trunks, well, then we'll automatically drop the call. This is useful in an organization where we maybe have slow networks or we have slow gateway responses. This could result in the call getting dropped unnecessarily. The default value for this is true. If you need to, you can set this to false. And then there's media bypass, as we discussed in the optimizing section for planning. If we wanted to enable media bypass for this particular gateway, we would simply set the media bypass parameter to true. Now that we've talked about registering the session border controller with the service, let's step this all the way through from creating the gateway to creating a simple voice routing configuration. So, as we talked about on the last slide, our first mechanism is to ensure that we register the session border controller with the service. And here you can see I'm using new CsOnlinePSTNGateway to register the session border controller with a SIP signaling port of 5068 to the service. As we talked about in our planning, in order for me to be able to set up my voice routing, I need my combination of usages, voice routing policies, and routes. So in this case, since this is a very basic configuration, I'm going to create a new usage, set CsOnlinePSTN usage, identity of global, and then I'm going to add this new usage name, and I'm simply going to call this usage unrestricted. I will then associate that usage with a new voice route. So here you see I do my new CsOnline voice route. The name of the route, I'm also going to call unrestricted. And you'll see my number pattern here is .star. That's basically a catch-all. It's going to match any number pattern. My online PSTN gateway list is my session border controller, SBC1.contoso.com. It's priority 1 because this is the only route that I have. And here I've associated the usage, online PSTN usage, that I created earlier to this voice route. Right? So there's my usage of unrestricted. There's my route of unrestricted with this gateway, matching basically any going to this session border controller. The last piece of the puzzle is to create the voice routing policy. So I do new CsOnline voice routing policy, In this case, I also called this unrestricted dash online PSTN usages. This is what links the PSTN usage of unrestricted to this voice routing policy. And that's what we've done right here. So now my usage is linked to the voice routing policy. My usage is then linked to the route. My route is then linked to the session border controller, and we are ready to roll. Let's look at a slightly more advanced routing configuration here. Much like we saw in the previous one, we're going to start by registering the online PSTN gateway. In this case, because this is a little more advanced, I want to have some additional redundancy. So I'm going to build multiple session border controllers into the service. So here we go. There's my commandlets for SBC1 and SBC2. I'm going to create a PSTN usage. This time, this usage is specifically for making calls to the US and Canada. Now again, this set CsOnlinePSTN usage by itself really doesn't do anything, because you notice this usage isn't really tied to anything. It's not tied to a routing policy, it's not tied to a user, it's not tied to a gateway, nothing, right? I'm going to build out my voice routes. My first voice route, I'm going to do specific to +1425 and +1206. These are my Redmond numbers, or my Seattle numbers. So there's my new CS Online voice route. I call it Redmond 1. My number patterns that I'm going to match, my gateway list, priority, and then map that to this usage, as you see in the visual on the left. I have another pair of SBCs, 3 and 4, that I added into the service. And I have a new set of routes, new CS Online voice route. This happens to be Redmond 2. Now you notice this has the same number pattern that we see for this first route, but notice what's different. Different set of gateways and different priority, right? So now this Redmond 2 route, this is a backup route. As long as these session border controllers are available, this route has the higher priority. This will always be used. If both of these session border controllers go down, this would not be a valid route. We would fall to this route, and I would send the calls out through SBCs 3 and 4. So now I have a little bit of redundancy. 2 more session border controllers in the mix. I've added 5 and I've added 6. And here's my voice route for the remaining calls. New CS Online voice route, identity, other +1. So this is basically anything that starts with +1, as you can see by this number pattern. It's a full 11-digit dial, but starts with +1. My gateways are SBC 5 and 6. And again, I've linked it to the same usage of US and Canada. So now my usages are linked to my respective routes, which are linked to their respective gateways. Now I can build my voice routing policy, new CS Online voice routing policy, and I can associate this US and Canada usage with this voice routing policy. And away we go. Now again, at this point, all we've done is configure all of the routing. We haven't yet assigned it to the user. We're going to do that as we go through the next couple of steps and we get a chance to actually enable the user for direct routing. Number translation is an optional step that we could use. It may be necessary for interop with various session border controllers in specific scenarios. Now, the number translation rules are applied at the gateway or at the SBC level, and they can be applied in both directions, meaning they can be applied inbound. That would be a call that comes in from a PSTN endpoint to a Teams client, or they could be applied for outbound calls. That would be a call that starts with a Teams client and goes to a PSTN endpoint. All of the number translation is accomplished using Tenant Remote PowerShell, or TRPS for short. In Tenant Remote PowerShell, we create and manage these rules with the CS Teams Translation Rule commandlet. And you have various verbs, action verbs for that. So new CS Teams Translation Rules, set, get, remove, so forth. These translation rules will affect the request URI from and to headers in the SIP dialog between the session border controllers and the service. You will then create these rules and assign them to the gateway. The rules get assigned to the gateway by utilizing either the new or the set CsOnlinePSTNGateway commandlet. and you can see the parameters that I have listed at the bottom here let us know what direction the translation rule is going to apply. Is it inbound or outbound? And whether we're going to operate on the Teams number or the PSTN number for that particular translation rule. Let's step through an example of number translation for an inbound call. If we take a look at this screen here, I have my session border controller, which is configured with direct routing to Microsoft phone system to my service, right? And this session border controller is connected via SIP trunk to a legacy PBX. This could be our old, Cisco or Avaya PBX that we're using. I have a user, Bob, who is still utilizing his legacy PBX. And then I have a user, Alice, who is configured with Teams and direct routing. And in this particular scenario, Bob, whose extension is a short 4-digit extension of 2814, Bob is going to use his old handset to make a call to Alice. Now, Alice isn't on the legacy PBX anymore, but hey, Bob doesn't know that. All Bob knows is he wants to pick the phone up and dial 2814, and Alice should answer. When he calls Alice, he knows to call Alice by her 4-digit extension, which is 4825. Now, in Teams, we will be using the E.164 notation to represent the user's phone number. So Alice isn't going to have a phone number of 4825. She's going to have a phone number that's properly formatted as an E.164 number, which would start with +1. Likewise, when Bob makes the call, his caller ID should be reflected as E.164 as well, so that Alice will have proper name resolution, or what we call reverse number lookup, and she'll actually see that it's Bob calling and not just extension 2814. Well, in this instance, the legacy PBX is using 4-digit dialing, and Teams is using E.164, so we're going to need to translate the 4-digit numbers from Bob and Alice to E.164. Now, we need to pay attention to the direction that we're working with here, because Bob is making the call to Alice. So from the Teams point of view, this is an inbound call, right? The call is coming into the Teams environment. To achieve this, we need to create and apply a set of translation rules. First, I'm going to create 2 different translation rules here. The one translation rule that I'm going to create is going to simply add the +1 into the environment. The second translation rule that I'm going to add is going to add the Seattle NPA and NXX values, right? That's the area code and so forth. So you'll notice here, for this second one, when I see 4 digits, I'm going to prepend it with +1, 206, which is the area code, 555, which is the exchange, and then the $1, that's the variable for the 4 digits, right? So these are my translation rules that I've created, and then I'm going to take these rules and I'm going to apply them in the following fashion. When I apply the translation rule for the inbound Teams number, right? Remember, this is inbound, is to this direction, and the number that I want to affect is Alice. That means that I want to turn Alice's number from this 4-digit extension into a fully formed E.164 number. So I will use this inbound Teams number translation rule, and I will pick my rule of add E.164 Seattle NPA NXX. Here's what happens. On the request URI, the invite from the PBX, all it knows is, hey, I'm sending a call to 4825 because that's what Bob dialed. But on the Teams side, when this invite reaches us, we're going to change that from 4825 to +1 206 555 4825, right? We're going to prepend this info because now this is a fully formed E.164 number. And when this makes it all the way through the team service, we can see that that is Alice because that's Alice's fully formed phone number, right? The same thing happens with the to request because this is who the call is destined to, right? The to is the 4-digit number. I use the translation rule to make it fully formed as E.164 because I'm using that inbound Teams number. Now, the second piece of this was for caller ID, right? Bob's extension is 2814. The PBX itself, when it sends the call across this trunk here, right, it's actually sending it almost as an E164 number, right? This is Bob's actual phone number, 949-555-2814. So it's close, but it's not quite E164, right? It's only 10 digits that I'm dealing with here. So when I do this inbound, because again, remember it's inbound into Teams, right? But now the number that I want to manipulate is the PSTN number, right? I want to manipulate Bob's number because Bob's number doesn't have a +1 on it. So I'm going to manipulate his inbound PSTN number. I'm going to add +1, and that's going to translate his number into +1 949-555-2814. And now when Alice receives the call in the toast that she gets in her Teams client, she'll be able to have a reverse number lookup for that E164 number, match it to the contact for Bob, and now we know that it's Bob that's making the call. Now, this is a way that we can achieve number translation through Teams. It's also possible to do these types of translations right here on the session border controller. It's up to you where you choose to do this, or maybe it isn't, depending on if this is a hosted environment. But the key to this is you only want to make these types of translations in one place. Either do them here on the session border controller or do them here inside of Teams. But generally speaking, we don't want to do them in both places. Now that we have the session border controllers registered, we have the voice routing configured, the last step of the puzzle is to provision the user. Now, the users can be provisioned to only use direct routing, or they could be provisioned to use both direct routing and calling plans together. Let's start with direct routing only. So the first column here, again, make sure that we have the correct licenses applied to our user. Where do we provision the phone number? Well, when they're direct routing only, we'll provision this in Azure Active Directory. This will either be done online or you can do it through the on-premises environment with an Azure AD Sync if you like. That might come into play if we were dealing with migrations from Skype for Business Server, for example. But the number is provisioned through Azure Active Directory. We can enable the user quite simply by using a set CS user commandlet. So here, you see in this commandlet, set CS user, my username, the -on-prem line URI is the phone number that we're going to assign to this user, and this should be in E164 format. -enterprise voice enabled true and -hosted voicemail true basically lights up the phone system, direct routing, and cloud voicemail components for them. Now this enables the user, but there's no routing mechanism that's assigned to the user yet. Remember a couple slides ago, we configured all of that voice routing, but the last piece for that user now is we have to assign the voice routing policy to them. And we do that through this grant CsOnline voice routing policy commandlet. That's my user, and there's the policy that I would like to assign to that user. Now in this case, in the first column, remember from a routing behavior perspective, only the routes that I've configured through this voice routing policy are evaluated. So if there's no route that matches, the user can't make a phone call. And because they're only provisioned for direct routing, that's their only way to make the call. If the route's not there, the call drops. If we look at the second column, this is where we configure this individual user with both direct routing and calling plans, right? So same base licenses that we saw before, but now we've also assigned a Microsoft calling plan to the user, and that would be domestic or domestic plus international. One of the main differences here in this scenario, though, is the number provisioning happens through Microsoft. This is not a number that you assign through the direct routing environment. This is a number that is acquired from the Microsoft service or a number that you port in to phone system in the Microsoft service. Right? So this is a number that gets assigned through the Teams admin center or using the set CS online voice user commandlet, right? Not set CS user, set CS online voice user or the Teams admin center. Basically, you are provisioning this user as a calling plan user. You're just also giving them the ability to use direct routing for routing decisions, but their calls inbound are anchored on the calling plan phone number. Now, again, you can assign the voice routing policy the same way you did with direct routing only. Here's the difference. From an outbound routing perspective, first thing that we do is check all of the routes that are here in this online voice routing policy to see if we can route. If we don't find any matches there, well, then we'll fall back to using calling plan and see if they have a domestic or an international plan. And if they do, then we'll route the call out through calling plans. This is very advantageous where perhaps you've given the user calling plans because it's more beneficial to them, but maybe the user also has to still be able to do calls to an on-premises PBX. This allows you to route those calls to the on-premises PBX through the direct routing environment, but then route all other calls through the calling plan infrastructure. If you want to look at the dial plans that we talked about in our planning session, you can see on the left side here an example of PowerShell commandlet that lets you see the base normalization rules that are in the service country dial plan. This is an example of the service country dial plan for the US, but you could substitute that with any particular dial plan like you see in the screenshot there. You could then go into the Teams Admin Center and create your own tenant level dial plan if you so desire. Like we discussed in our planning session, you could either edit the global, which again would apply to everyone in the tenant, or you could click add and build your own custom dial plan. And then you could assign this particular dial plan to an individual user, either through the UI here or through Grant CS Tenant Dial Plan. And then remember that you can use the Get CS Effective Tenant Dial Plan to see what that merged dial plan would be for an end user. Now let's talk about configuring local media optimization. From a configuration standpoint, when we go to configure local media optimization, we first need to ensure that we configure our trusted IP addresses properly. This is to ensure that we understand when a user is inside the corporate network versus outside of the corporate network. We also then want to be able to locate that user inside the corporate network, which takes us to step 2, which is defining our network elements. These are our regions, our sites, and our subnets. From there, we'll define the virtual topology, which is basically configuring the proxy session border controllers as well as any downstream session border controllers. From there, we then need to configure the SBCs themselves for local media optimization. That is vendor-specific guidance, so we need to make sure that we get the correct configuration information from our SBC vendor of choice. And then finally, we would configure the voice routing pieces, which is exactly the same as we had seen before, which is the ability to just assign an online voice route to a particular session border controller as the target. Now, as I go through these steps, I'm going to use a configuration example as my guide. And this example you might recognize from our planning session. This is our APAC example. And as you can see in this configuration example, we have 3 sites. We have our Singapore site, which is the site that actually has internet connectivity as well as the public IP address for the session border controller. And then we have 2 additional branch office sites, Vietnam and Indonesia, as you see here. These sites also have session border controllers in them, but these session border controllers don't actually have public IP addresses assigned to them. Now, these particular sites, the branch offices of Vietnam and Indonesia, they do have local internet breakout, right? So from an end user perspective, I can browse the web, but there was no capability for us to assign a public IP directly to these session border controllers. From a WAN connectivity perspective, the Vietnam and Singapore sites and the Indonesia to Singapore site, that's good connectivity, right? But between Indonesia and Vietnam itself, that's not so great connectivity. So we want to keep that in mind as we start looking through the configuration steps over the next set of slides. So our first step is to configure the trusted IP addresses. The trusted IP addresses are the IP addresses that the users would be using when they browse the web and actually hit the Office 365 service. So each of the respective sites that we looked at, Vietnam, Indonesia, and Singapore, they all had local internet connections, right? So when our users would connect to the service with their Teams clients, these are effectively the NATed IP addresses, public IPs that we would see for these users. So I would add them either using PowerShell, as you see here, new CS tenant trusted IP address, or I could do this through the Teams admin center under network topology, flip over to the trusted IPs tab and click add, and away you go. Important thing to note here when I'm adding these addresses, I'm using a mask bits of 32. That indicates that I'm matching this exact IP address. Now, of course, that's not a public IP, but you get the point. This would actually be a public IP address that your users would be using when they egress out that internet connection. Our next step is to configure the associated network elements. And again, these are the same elements that we would use if we were doing location-based routing or potentially dynamic emergency calling. So if you've already configured those, you might be able to reuse some of these components. If you haven't, then we simply need to define regions, sites, and subnets. So you can see here, I've built out my region as APAC. I built out my sites as per the example, right? I have my Vietnam site, I have my Indonesia site, and I have my Singapore site. And you notice that all three of them are tied to the same region, tied to the APAC region. And then I've built out my appropriate network subnets. CS tenant network subnet. These are my subnet IDs, masks, and the network site ID that they are associated with. Now, a key piece of the puzzle here, the network configuration service has a roughly 2-hour cache window. So newly created configuration settings like trusted IPs or things of that nature may not be directly available until roughly 2 hours after creation. So just keep that in mind as a buffer. If you're doing some testing and you go and create one of these things and you don't see an immediate response, it might be because the NCS cache hasn't flipped yet. So you haven't been able to see that new change that you made. Our next step is to define the virtual topology itself. This is the configuration of the proxy SBCs and the downstream SBCs. Now, remember in the example that we were looking at, there's a total of 3 SBCs. The one that's in Singapore, that's my proxy SBC, because he's the SBC that actually has a public IP address assigned to him. My other SBCs are downstream SBCs in Vietnam and Indonesia, respectively. Now, the proxy SBC, it's defined pretty much the same as we had seen defining session border controllers before. We use the new CsOnlinePSTNGateway commandlet. We give it the FQDN, the port that it's going to use for signaling, the max concurrent sessions, great thing to do, the gateway site ID, right? That's the matching site that we built, and this is case sensitive. So make sure that you match the case that you did here with the case that you did when you created the site, on the previous steps. The media bypass flag needs to be set to true, right? That's in our planning session. We kind of talked about the on-off switch for media bypass. That's the on-off switch, right? Media bypass is set to true. Dash bypass mode. This is always in this particular example, right? Remember we talked about in our planning session, this could be either always or it could be only for local users. So we've set this guy to always because he has good connectivity. And of course, don't forget to enable it, dash enabled true. Now this SBC might already be defined in the topology. Maybe you just didn't turn on media bypass. That's cool. You could also use the set CSPSTNGateway commandlet and add the gateway site ID, media bypass, and bypass mode options as appropriate. Our downstream SBCs, this is the ability for us to effectively build that virtual topology. Let the service know that these SBCs exist, even though they don't have a public IP. So, new CsOnlinePSTNGateway, similar command, right? The identity, that's the FQDN, if you will, of that particular device. The signaling port that it's using, again, that's how you've configured what you chose on the SBC. This is the key part, dash proxy SBC, and then the FQDN of the proxy SBC. This lets us know that this is a virtual definition of a gateway. I'm not going to try to talk to him directly, but if I need to talk to him, I talk to him through this proxy SBC. Gateway site ID, again, case sensitive. Media bypass has to be true. Bypass mode, well, in this case, I've chosen only for local users because I don't have great connectivity between Vietnam and Indonesia. So if I have a user that's in Indonesia and they want to send traffic out through the Vietnam gateway, I don't want them to talk to me directly. So you have to be in the same site as this session border controller to be able to talk to it directly. And I do the same thing here for the Indonesia session border controller. right? Again, it's important to note, gateway site ID is case sensitive. So as you see here, Vietnam with a capital V and Vietnam with a lowercase v would be treated as different sites. So be aware of that. The domain that you use for the downstream SBCs, right? Here I have, .contoso.com. That actually can be a domain that maybe isn't even configured in the tenant, right? Maybe it's, the vnsbc.contoso.local for whatever reason. That's fine. You can use that as long as you use the -proxy SBC parameter. If you forget this and you try to put a name in here that doesn't match the domain list that we have in the tenant, you're going to get an error. Right? And again, remember with the only for local users option, the bypass mode, right? Local media candidates are only going to be offered to the Teams client when that Teams client is in the same location as the SBC, right? The same defined site as the SBC. In all other cases, media is going to flow via the internal or the external IP address of the proxy SBC. And again, that's going to be determined on whether the user is internal, right? If the user is internal, it'll flow via the internal IP of the proxy SBC. If they're external, then it's going to flow by the external IP address of the proxy SBC. From there, you're going to make sure that you follow the vendor's documentation to properly configure the session border controller for local media optimization. And then you'll go ahead and configure voice routing as outlined in our voice routing sections of our planning and our configuration modules, right? These downstream SBCs will show up as gateways, right? You build your routes, you'll point it to these gateways, and away you go. Now let's talk about the tool sets we have for managing direct routing. When we look at the direct routing environment, as we've talked about before, we have our session border controllers, we have the PSTN network, perhaps we even have a third-party PBX in the mix here. How do we look at the environment and manage what's going on here? Well, first and foremost, if I'm looking at the connectivity between Teams and the session border controller itself, I can use tool sets such as the call quality dashboard or the call analytics. Now, the difference between the two, call quality dashboard, which you can find at the URL that you see here, call quality dashboard is a near real-time dashboard that allows us to see the calls that are being made by a user containing all of the end user identifiable information. This is data that's aggregated as well so that we can start to see trend analysis of calls that have been made by the direct routing infrastructure, among other things, right? This does contain end user identifiable information such as the wireless access point, the SSID they were connected to, their call details, their user IDs, their full IPs, MACs, and so forth. So there's lots of great information that you can drill down into utilizing the call quality dashboard. Plus, it gives you that aggregated view of calls over time. The call analytics tool, on the other hand, is a tool that we can use to dig deeper into an individual call, right? Call reliability and availability for an individual call. So maybe a user indicated that I made a call yesterday at 2 in the afternoon and that particular call had some poor quality. I could use call analytics to drill deep into that one specific call. Additionally, because the session border controller could be talking to other environments, we have logs that we can pull from the session border controller itself to help us debug or troubleshoot any particular issues we might be having. And if the session border controller happens to be talking to, say, a third-party PBX, there might be logs that you need to collect from the third-party PBX as well. Lastly, we have our PSTN providers, which you may need to dig a little deeper into with your carrier of choice to get some additional visibility into the PSTN provider side of the equation. In the service, we do provide a health dashboard to look at the overall health of our connected session border controllers. Often this is the first place to start because if the session border controller isn't successfully connected to the service, nothing else is going to matter because we're not going to be able to make or receive calls through that session border controller. So as you can see in the screenshot, if I navigate to the voice blade and go under direct routing, I will be able to see all of the session border controllers that I have, as well as which session border controllers might have issues, right? And each of these are hyperlinks that we could go through to see what these particular issues might be, whether it's with SIP options, whether it's a failure with TLS connectivity, that's our signaling channel, right? Whether our network effectiveness rate or NER rate is below a certain threshold, right? If we've met our current capacity for calls, we can very easily at a glance see what's going on with our session border controllers. I can then click on an individual session border controller and go deep and see with that particular SBC, when did it last connect in with TLS? Am I getting and receiving options properly? Right? What's my NER? What's my network effectiveness ratio, the average call duration, and so forth. So lots of good telemetry and detailed information that we can get even as we drill down into the respective SBCs. If you look at the aka.ms link in the upper right, you can see our published documentation on the health dashboard. This is a table that shows some of the more common configuration issues that we see with a session border controller. I'm not going to take you through every single one of these, but some of the more common ones we see are, for example, the second one, failed to verify peer certificate. The session border controller infrastructure utilizes TLS, mutual TLS, right, to ensure that the person on the other end or the device on the other end is who they say they are. When your session border controller is talking to the Office 365 service, our service uses certificates that are actually generated by a certificate authority that uses the Baltimore root certificate. If you forget to import that root certificate into your SBC, you may not trust the certs that are coming from the service, and that's why you'll get this fail to verify peer certificate. All of the vendor documentation for the various SBCs have a step that talk about how to import this Baltimore root certificate, for example. You may also see errors. These are errors you might see in SIP logs on the session border controller, like 404 not found for incoming calls. That usually means that we can't find the phone number. So either we didn't configure the user's phone number correctly in the service. So if we were configuring them with the on-prem line URI parameter, perhaps we had a typo in that, or we're not translating it properly. Maybe we forgot to include the plus sign or fully form it as E.164, and the number just simply doesn't match. Now, inside of the call quality dashboard, we have also exposed a set of Power BI reports. These Power BI reports include a set of summary reports, the various help desk reports, location enhanced reports, mobile device reports, and for the purposes of this training, PSTN direct routing reports that let you drill into more and more detail of all the calls that were made through the PSTN direct routing infrastructure. And then there's also a user feedback report. These reports are available through the Call Quality Dashboard portal itself, which is at cqd.teams.microsoft.com, but they can also be downloaded to be used with the Power BI desktop application. So if you go to the aka.ms link that is on the slide here, that will take you to a page where you can find a hyperlink to download these PBIX files that you can use with Power BI desktop. It's a very powerful way to gain access to the Power BI reports without having to navigate to the online version of CQD. Let's summarize what we've talked about in our direct routing sessions. Our key learnings. Direct routing allows us to connect our existing phone infrastructure to the Microsoft Teams environment. To successfully configure direct routing requires a certified session border controller. And we've covered the key pieces of configuration for direct routing, but we have lots of documentation that go into great detail on all of the additional configuration that you may want to do for the direct routing environment. In this lesson, we completed the third and fourth bullet points on the slide, which were configuring and managing direct routing. Now that you've completed this lesson, you should move on to our next lesson, which is migrating to direct routing.